Okay, so let's do an example. I'm going to read the example and write down the information. So it says, suppose that $5,000 is invested and pays 6.5% per year under the following compounding options. Find the total amount after 10 years. So in this case, we're investing $5,000. That's our principal amount. So P is equal to 5,000. And it's $5,000. Okay? It's invested into an account that's earning a rate of 6.5%. Now, we always put rate as a decimal, so we don't put it in as a percentage. So 6.5% would be 0.065. Okay? And the amount of time that's going to pass is 10 years. And they want to know what would be the accumulated amount under the following compounding options. So the first one, part A, says for annual compound. So annual compounding, that means that n is equal to 1. And so that means our formula is going to be A equals P times 1 plus R over n, which is 1, so it'll just be R. And since n is 1, it's just going to be T. And that's our annual compounding formula that we saw before. Okay, and so if we just plug our values in here, so it's going to be 5,000 times 1 plus 0.065, so that'll be 1.065 raised to the 10th power. And so all we have to do is use our calculator to do that. We'll round to the nearest dollar. Always remember to read the problems carefully, because they will tell you like when to round or how much to round. And if it doesn't say, then like in these cases, you just round to the nearest penny. Okay, so we take 5,000 and we're going to multiply that by 1.065 raised to the 10th power. And we get $9,385.69. So we just round that to 93.86. Right? So 93.86. So this would be $9,386. Now for part B, they say, okay, let's do the compounding quarterly. That tells us that n is equal to 4. So now our formula is going to equal A equals 5,000. Well, let's do it this way. Let's write out the formula. So it'd be P times 1 plus R over n, because n is not 1, it's 4, raised to the n times t power. Okay, so now P is 5,000, R is 0.065, n is 4, so we're getting a quarterly rate, and then we're going to raise it to the n times t power. Okay, so that's going to be 5,000 times 1 plus 0.065 divided by 4 raised to the 4 times 10, which would be 40. Okay? So now get our calculator. And in this case, it's going to be again 5,000 times 1 plus 0.065 divided by 4 raised to the 10th power Yeah, that doesn't make any sense. Hold on. Let me try it again. Let me do this a little differently. 0.065. Let's do 0.065 divided by 4 plus 1. And we're going to raise this. Oh, that's right, it was supposed to be 40. I'm sorry, that's where I made my mistake. So raised to the 40th power. Okay, and all right, so now when you do it quarterly, the accumulated amount, the future value, is $9,528, round to the nearest dollar. So it went up a little bit more. So, okay, now the next one is monthly. So now that means n is going to be 12. So I'll just put n equal to 12. So it's monthly. And so that means A equals 5,000 times 1 plus 0.065 over 12 raised to the what? Well, now it's going to be 12 times 10, which is going to be 120. So again, let's do that one more time. So that's going to be 0.065 divided by 12 plus 1 raised to the 120th power times 5,000. And now we get 9561. So this is going to be 9561. And now let's do it again. So now we're going to go to daily. So that's going to be what? N equals 365. And that means A is going to equal 5,000 times the quantity 1 plus, now it's going to be 0.065 divided by 365 raised to, well, in this case it's going to be 365 times 10, so that's going to be 3650 as the power. All right, let's see what that gives us. So 0.065 divided by 365 equals plus 1 equals raised to the power of 3650 and times 5,000. Now, if it's compounded daily, the amount that I end up having after 10 years is $9,577. And then finally, continuous compounding. Well, with continuous compounding, we use a different formula. So that's going to be A equals P times E to the RT. And so this is going to be 5,000 times e to the 0.065 times 10. And so now let's do that one. So it's going to be, where's my e? So e raised to the 0.65 power times 5,000. And so now we get 9,578. Okay, so now let's look at the result here. Okay, so now notice for annual compounding we ended up with $9,386. And then when we went to quarterly compounding, the total amount we got was went up by went up by about $150. Okay, and then when we go from quarterly to monthly, it goes up to $95.61. So now it only jumped up to went up about $30, right? And then if we go from monthly compounding to daily compounding, it went up from 61 to 77. So you're looking at a $16 jump. And then to go to continuous compounding, it only jumped up once. So as you can see, as you increase the number of compounds, the amount that it increases gets smaller and smaller and smaller, which means that there's a limit, right? There's a maximum value that this is approaching, okay? Which again, under continuous compounding, that it would be the 95.78, okay? So I thought that was interesting. Okay, have a great day.